again, as we discuss this concept, you can comment in the comment section below if this reminds you of like any project you've worked on. So we'll be discussing on finding our data sets for this series. Roboflow Universe is a free library. Let's check it. Roboflow Universe is a free library of annotated computer vision datasets, pre-trained models, an environment where you can train your model. So we can search for our dataset, YOLO. We already have it open here, which I'll be attaching to the video description. So this has about 2,974 images across 6 classes: apple, banana, grapes, kiwi, mango, orange. So you are free to use it with attribution. So this is the dataset page. So for us to download these datasets to our device, we can do it in several ways, but we'll be using one of the ways. So when you click on download datasets, you click on download datasets. You can either train the model on Roboflow itself, but one caveat is you actually need to create an account to have access to these features. So download datasets. So instead of downloading to computer, I'll just say show me the download code and continue. So I would copy this and come here to download datasets in our scripts and paste the code. There is an important instruction here that we need to have Roboflow installed. So let's install Roboflow. So let's add it to our requirements.txt, Roboflow, and let's clear our terminal. So I can then run this by running Python scripts download data sets.py. So script. Oh, I got that wrong. Dataset.py. So it downloads the datasets for us. So through the API. But before we proceed, we need to discuss something. This dataset has about, which we eventually see, about 2,697 training images, but only 90 test images, which we would eventually see for a 6-class problem, which we would also fix. The classes are also a bit problematic. We are going to fix them along the way. So that is like, for a 6-class problem, that is like 15 test images per class on average for our test data sets. So that means this is not enough to trust our test metrics. In our subsequent videos, we are going to build our own splits from the annotated samples. We are going to use like a 70-20-10 and explain exactly why. This is not a criticism of our data sets. It is a teaching moment. Real-world data sets often have lopsided splits because the people who created them optimized for training performance. As an ML engineer, it is your job and your duty to recognize this and fix in your own pipeline. So this has downloaded, and as you can see, we have it here, but we don't need it here. We need it in our data folder in raw. So we just have to highlight them, highlight the train, highlight the test, highlight the validate, highlight the data.yaml, highlight the data set, and so on and so forth. So we move it into our raw folder, and we delete this since it is empty now. So as you can see, we've downloaded our data set and we have moved it to our raw folder. So this already download data sets in like YOLO V8 format, which would also work for other newer models, as you can see in the code board. This is layered in a way that we have tests folder, we have the data.yaml. This is something we would have to fix, right? We have apple, we have banana, we have grapes, we have kiwi, we have mango, we have orange, we have pineapple, we have sugar apple, we have watermelon, which is 9 classes, but we are going to be working with 6 classes. You don't have to worry about that. I'm going to discuss about that in the next few minutes. So the way YOLO organizes or expects your data organized is you need to have a test folder, a train folder, and a validation folder. And inside each of those folders, you need to have your images and your labels. So your images needs to have the same names as your labels. So the only difference that should be there is the extension name. So if you look at this, right, we have Apple branch 3282.882 JPG and so on and so forth as the first image. If we check our labels to the same thing. So it is important your data is structured this way. If not, it would affect the way your model is trained. So what does this mean? You only expect a specific structure, an images folder, and a labels folder for each split: train, test, and validation. Each image has a corresponding txt file. Let's look into it. And with the same name in the labels. Each line in the txt file is one bounding box, class ID, x center, y center, width and height, like we discussed in our previous sessions, all normalized to 0 to 1. The YAML file tells the YOLO where to train, where the train, test, and validation data live, and what the class names are. If this structure is wrong, training will fail silently or give you nonsense results. So this is data.yaml. So this stands for 0, 1, 2, 3, 4, 5, 6, but this is something we'll be fixing.